All right. Okay. So for instance, right here, I can do a var, a CNT, a counter. So this one is going to be an integer. So what I'm trying to do is I need to stop this somewhere else, right? So that simply means what I actually need to do is I can actually create a self folder here, and then simply um, I can do this. So for instance, CNT plus equals 1 every times, and if CNT um, is less than 10, all right, if that is true, I can execute this code here, right? But usually I want this one to execute before the incrementer, right? Good. Okay, and logically speaking, we want this one probably with 40 and a 40, and every time it basically moves by its actual size. So therefore, the moves can be better displayed. So let's check this out a little bit quicker, right? And then as you can see right here, one, two, right? Okay. We'll stop at 10 because I set a counter here. Well, it runs. So let me change that into Y. And let's run this code a little bit quick. All right. So let me use the bathroom real quick. I'll be right back. All right.
Oh, okay.
All right, Alex, can you hear me? Hello,
Yeah.
Alex. Can you?
Yeah.
Yeah. So this one makes sense, right? Okay. And I can tell you, so this one keep increasing this stuff and keep doing that. So, and if that is less than this and else, you can definitely say timer period invalid. So we'll stop the timer. All right. Okay. So Mark is here. So I'm going to. All right. Hello, Mark. Can you hear me?
Yeah.
Good. So I'm going to still wait a sec. There we go. So right now, for this part, just the automation because basically, let me clarify this. Um, AI agent, one principle, one principle is automation. All right. So we want our products to have all of the six principles of AI agent concept here. So timer is well, the very basic um, um, the automations here, right? So and then we can also add another if statement, right? So and the else if CNT is bigger than equals to 10, and we can use AND operator, and the CNT is less than maybe 20, right? So we can simply make this one right here, and we can turn it into the x coordinate here. And we can also save, right? So let's original y to be player period center period y. And then we can reposition the player's location by this, right? So this is the concept of what? This is the concept of swap algorithm. All right. Anything else that simply means is bigger than that. Well, the timer stops here. So overall, uh, we can see the 1, 2, 3, 4. It's basically well like a zigzag stuff here. So this will support our visual detections. So we can let user eye pupil to track this with automation stuff like that. So and therefore all you need to do just will add more conditional statement here, right? This is starter kit for you. And some inspirations from a lead code problem. And Mark, you'll be doing lots of these kind of stuff at CMU as well, the algorithm stuff here. Those are all the fundamental knowledge here. And I'll be placing this one here. So Mark, today's basically keep working through with Alex the grid stuff. All right. Okay, good. Okay, so then I'm going to hand over the command to Mark. Alex, ask any question if you don't know. All right, good.
Okay.
All right. So, and we just need to finish up some stuff. So we finished the right, and so for the we finished the left, and then so for the right, I kind of copy paste the stuff, but um, just one small thing is instead of doing a double for loop, we need to do a for loop, and then this is like the only way to do a backwards for loop in Swift. Because so here's like the example. If we used what we did for the left one, which is we sort starting from the left to right, we shift from left to right. That's fine normally, but when you shift to the right, this is kind of what happens. So this is like an example of our array. And then you see if we shift the left, if we're shifting right and we start from the left first, basically it'll move the leftmost one will move to a position that one of the ones ahead will also is currently at, which when that one moves, it'll clear out the eye, which kind of caused the pupil to shrink, if you remember that happening.
Yeah.
So this is like a example here. I left it as a comment, so later on, if you want, you can just read this. But this kind of just shows what's happening. So, do you have you done computer science AP?
No.
No, okay, that's fine. Well, this is like because Swift apparently doesn't have the built-in for loop to go backwards. So this is kind of the substitute. So you do stride. That's just a keyword, and then in here is like you'll recognize this stuff later if you do CSA. From is your starting index, through is your ending index. I wrote if you change through to I think by, it changes from exclude or include. I think there's a note somewhere here. Yeah, here. I left a lot of this note because this is all new stuff as well for me. So just a small little note you can review later on. But just know that this is like the best way to do it backwards for loop in Swift. And then the rest of the code is pretty similar. The only other thing I changed, I believe, is we start from the rightmost uh, grid or coordinate. So if I can find that code, give me a second. Uh, oh, also for this one, I just changed it so it's a bit easier to read. I preset row call. So instead of seeing pupil matrix in here and this in here, it's a bit neater. That's all. There's no other difference. Um, oh yeah, no, this is fine. Yeah. Oh, what I changed was right here. This is what I changed. Remember, abs is just absolute value because we need to find the distance between the pupil and the part where the user tapped. And so, yeah, the only thing I changed is here compared to the left function. So the left one, we use the top left coordinate as like the base. For this one, we use the top right coordinate. So it's row 0 and the last one in row 0. And we're using their x coordinate. So after I finish top and bottom, we'll go over the whole thing as a whole. But for now, give me a second while I just quickly finish this up. So for top and bottom, we just kind of reverse some of the logic. Right? Bottom is easier because well, it depends, but be a sec. Yeah, let's do bottom first. So this time we'll check the the y coordinate and do different y this time. Uh, yeah, this we can keep. This gets the whole button at that point. 0 and 1. And then let's see. I think, yeah, what we really only need to change is one of these lines. Let me see how this plays out first. Should be plus. This will be plus because we're moving downwards, so we're adding to the y. So oh. Never mind. Give me a second. Uh-oh. That's not good. So some. Oh, oops. Wait, what is this? Huh? This is the right function. Uh, let's see. Oh wait, I had a Y. Uh, Y. Give me a second. Let's see. I don't know what's happening. Give me a second. Yeah, that's all right. Um, oh, that's why. That should fix it. No? Why is it going? Why is it going left? Oh, they should both be zero. My bad. Zero is Y, not one. No? Okay. Index. Hmm. Oh, we need to change our base. It shouldn't be the top. It should be one of the bottom coordinates. So instead of 0, 0, we can change it to pupil matrix dot count. Should fix it. Oh no. 0, 0. Oh, oh, I keep forgetting it's -1 for each of these. Ah, okay, finally. So we do have a slight issue, but that can be fixed. So the issue is, yeah, the issue again is I think we're starting from 0, 0. So we're starting top to bottom. That means we should reverse the inside here. So I'm just copy this over. Let's see. See if this fixes it right away. Perfect. I'm gonna finish top as well before I continue solving these issues because these are just visual, so it's no big problem. So for the top one, we now want to reference like one of the top coordinates. So we'll go back to 0, 0. This can be a regular for loop. And the only thing is now we're going to be subtracting y. Oops. Subtract. That should be it. Yeah. So, okay. So top is perfectly fine. I got it mixed up. Yeah. Top is fine. Bottom is the one that's a bit mixed up. So I think good way to remember is whichever side you want like the eye to move, they need to start shifting from that side. So if you're shifting to the top, it needs to shift top first. Shifting to the bottom needs to shift first. Bottom row needs to shift first. Top row needs to shift first. Left, right, same thing. Let me fix the left one really quick. Let's try something similar to right. So what I've done. Try. Hmm. Oh, oh, yeah, there's a little issue. Hmm. Before I fix this, give me a second. Let's see what. Okay, so it's somewhat working, but this is giving us a slight issue. Oh, people matrix. Zero. Yeah, that's why we're getting a negative value. But it shouldn't be. Oh, no, I think it's. Um, was registering as a top press though? see. Okay, it's throwing an error after I move it a bit and I click right below. So what's the issue? This is giving me a negative value. Matrix is 0. Yeah, the issue is it's registered as top, which is not correct. What if we... No, it's fine. Hmm. Do we need to... check something really quickly? Okay. They're updating, so that's fine. Is it doing this? Give me a second. Um, change the top. Oh, okay. What if we set these equal? No. It's going to true because sender.frame.max y is less than the pupil. Sender.frame.max y. This is the bottom right. Matrix 0. Pupil matrix 0. The count -1. This is row 0, top right. So max y is might change. No, this is fine. Oh my God. We're comparing a Y to a X. That's a big issue first. Uh, okay, let's see if this fixes anything first. No. Oh, no, it's not crashing. That's good. Okay, that's fine then. So I guess that issue is kind of solved. Okay, so now we just have the bottom left. Looks like our corners are fine, as generally fine. Yeah, so just our bottom function now. Sorry, that was weird. It was my mistake. When I was coding last time, I accidentally left this as an X, and that kind of messed everything up. Make sure you're comparing the same things here. Okay, give me a few more minutes. Almost done. Just check with the last bit here. Uh, I think this one, these two should be reversed actually. Let's change that. Yep, there we go. Yeah, I got a mix. So we need a okay. So first I'm gonna just explain the bottom bit. Since we're sorting, sorry, since we need the bottom row to basically shift first, the bottom row, we need to make sure that like the whole row is shifting that way first. So that means instead of the inside, because that would be the column shifting, we switch the stride to be the outer for loop, which is the row. That way, our first starting index for the row shift is pupil matrix.count minus one, which is the last row. And that's how we get it to make sure that the bottom shifts first. Okay, so this is it for the I. I guess we can start going over stuff you want to know first. Do you want to read the code first and ask after, or is there some stuff you want to know right away? We can go
Mm,
step by step again. So the
mm.
first thing I think we did was this bit, right?
Oh yeah.
Starting from here. So this is all just registering the taps. And on top of registering taps, we just keep track of if each coordinate, each direction was tapped or not by setting them to true or false. I guess the trickiest part of this one is knowing which coordinate or like, yeah, which X points and Y points you need to compare for each direction. And the other thing would be where I think this is where we basically start using three indices because normally we did 2D array. It's this is basically just that's one specific coordinate in the pupil matrix. And let me rerun this and clear my print statement. Just give me a second. Okay. So where are we at? Yeah. So the first two coordinates just get us one specific pair in here. And the second one or the third one is either the first coordinate or the second. And don't forget, we have these in y-x coordinates. So this would be row y, column x. And the reason why we do this is our pupil matrix stores the coordinates of the pupil in the I matrix. So that's why we reference I buttons. And then we get the coordinates on I buttons by accessing the y and x coordinates of pupil matrix. So like pupil matrix 0, 0, 0 is the 0th row, 0th column, and the 0th element. So that would be 3. So then basically this would turn into I buttons 3. And then the second coordinate would be 0, 0, and then 1, so 11. So this is just a way to get numbers, basically. And we repeat that for each of these. And so yeah, depending on if you're comparing y or x, we need to compare max y to min x, or the min x to max y, x, max y to min y to max y. This part you can just do graphically. So when you're looking at this I, you just need to think to yourself, this I'm trying to find if it tapped the bottom. So the area where they tap needs to be lower than the bottom of the pupil. So that means the area on the bottom has to be bigger. That's why we compare if like a box was here, the top of that box would still be considered below the pupil. So we check if the top of that box is below the bottom of the pupil. So the top of a box would be its min y, and the bottom of the pupil would be one of these coordinates is max y. So we can do that. And we have to do min y and max y because if we do center here, there's chances of overlap and it'll overlook that bit, and that'll cause issues again. So yeah, this part is, I wouldn't say it's too bad. It's just you need to get comfortable with this kind of ugly notation. This is where, let's see what this is. Okay, so this next part is, hold on. Okay, this part is pretty simple. We're just getting the location of which button was tapped. So to do that, we first set up our two variables. And then we're just comparing, we just do a double for loop to iterate through every element in the 2D array. And once we find one whose center is the same as the button that was tapped, that's sender, that one's center, then we just save them as I and J. So in a regular for loop, if we're doing it this way, I will always be a row, J will always be the column. So Y will be I and X will be J. And then break just stops the for loop from continuing because it's pointless since we already found our required point. And this is where we start. This is the hard part. So all 4 lines of code aren't like too different. They just have slight changes that you need to recognize. The left one's probably the easiest just because it's we naturally do a double for loop like this, and this just causes it to start from the left because both indices start with 0, 0. So that means you're starting with the top left corner of the pupil matrix, and then we're moving along top to bottom, so left to right, top to bottom. And that's just the natural order for if you start from 0. And in here, we first get the difference in x, which is the absolute value of the x coordinate of like the leftmost pupil, and then where the button was tapped. So if it's registered as a left, that means they tapped somewhere here. So we already saved the X of where they tapped, and now we just need to shift the pupil to where they tapped. And to do that is basically we need to make sure like it doesn't go over bounds. So the reference point we use is a point along the leftmost side of the pupil, and that's the 0th column. So that's why we just use 0, 0 because it's really easy to get. We don't have to type in like we don't have to guess with math or type in any long name. And then we get it to x-axis and we shift that. So then here, oh no, we subtract and that gets us the distance. And then once we have the distance for the x, we shift everything by that distance. And that's why we do this one. So we just iterate through the whole pupil. And for each one, we shift their x value. That's what the 1 means. Because remember, it's y and x. So we shift that x coordinate by the difference in space. That'll shift everything over a certain amount. This part is just resetting the buttons to like a clickable state. And then once we finish shifting it, we'll change it back to black and we'll change it to make it unclickable, which means it's a pupil button. So then right is kind of the opposite and is where like stuff gets a bit trickier because I think, yeah, so like I told you earlier, there's a big no here. Once you read this, you should be able to slightly get it better. But when we start from left, we shift left first. We make it clear, and then we shift it, and then we make it black. So everything will be like everything I need will be black, and everything I need clear will be clear. Because if this goes clear and turns white, this next column next to it would then turn black. And then basically all the following ones will turn like any clear ones in between, any clear columns in between to black because they need to move there instead. So like even up to the last one, it'll move one over and then it'll be clear. And we'll still have the whole pupil. But for the right, if we shift left first, this will be clear. And this part will turn black. But then this part needs to shift right as well. So then it'll be clear and then turn next part black. So then what the very first column turned black will then be turned clear because that column hasn't actually moved yet. And that's why we shift by the same row order. So that means we start from 0 in the rows for loop, which is the outer for loop. That's perfectly fine because nothing matters for rows. But for the J, we need to make sure the right side shifts first. And that's why we make sure the first index that shifts is pupil matrix I.count. So I doesn't really matter. It's just we could use 0 because a matrix is a square. So every row is the same length. But I just like to use I. There's no need to really, unless you want to reference the exact coordinates later on. So that's helpful sometimes. Oh, no, it doesn't matter. You can use 0 or J, 0 or J. It doesn't matter, but basically we need to make sure the very first index that shift is the last column. So that's how we get the like a specific row of the matrix, its length of that row, and then we subtract 1 from it because the max we need to account for the 0 index. And then from there, it's pretty similar. This part we subtract x because x is moving left, and so then we need to subtract. But when we're shifting right, we need to move it along the x-axis to the right. So that's why we add the x difference to each coordinate instead. And that's how we get the right part. Top is we change the x stuff to y first of all, including like the coordinate we reference here. So where it was 1 here, now we go to the y coordinate of the pupil. And we subtract it from the y we'd saved earlier. Then when we're doing top, it's kind of similar to left where we don't really need to change much. We just need to again, change the x parts to y. So that includes these indices. Instead of 1, it'd be 0. And bottom is like our right. So bottom is also a bit unique as well because first of all, we need to get a bottom coordinate. So I just use the bottom right coordinate, which is pupil matrices count -1. So that's the number of rows -1 to get the last row. And then the last column in the last row. So this is our bottom right. And then we get its y coordinate. Then we subtract from the top y. And we need to iterate this time with the reverse loop on the outside because we need to shift rows in priority first. So that's and they need to go bottom. So if we reverse it, this whole row will technically be first to go down. And the inside will be a regular for loop. And then yeah, it's not too different. Just change the plus and minus. And we have I guess we have the eye, a very rectangular eye. I can send you this code first. I know that was also a bit rushed, but I tried like just explaining everything I had to do. Uh, is there one part or any parts you like think you wouldn't get even after like trying to review this code? Or do you want to like review it really quick? I think these notes are pretty important.
Yeah. Could you wait? Could you scroll up a bit?
Yeah, just tell me when to
A
stop.
bit more. Yeah.
This is kind of going into old stuff, by the way, so I don't think it's here.
Yeah. I think I get it.
You get it? Okay. Everything, or you just need a little time to review later on, right? And then you should be fine.
I think it's fine.
Okay. In that case, I guess I'll ask the other Alex what we should do next. If he's here, let me message him again. 'Cause, we have the whole eye functioning. So when you get this code, just review it, and then you can just plan out where you want this eye to be. I want to personally try seeing if the size of the eye impacts how this function works. Like, give me a second. I do want to know what this is like. So we did a 5 by 10. Oh, but then it's gonna be out of index. 5 by 10. So this will be that's not different. We'll do 4 by 8. Or is this 6? Yeah, 4 by 8. See how this looks. Be 2 by 4. Wait, what? Hmm. Oh, oops, that's 82. Okay. No, what's wrong? This needs to go as well. Let's change this to. Well, let me make sure I didn't clear out anything important. Oh no, I didn't. Okay. Yeah, let's change this to 4. Change this to 8. So we have the pupil. Oh, it's a square. That's right. In that case, how do we get 8 by 8? I guess just do 2 by 2 then. Yeah. What? X out of range. Maybe it's too small. What if we did 10 by the original is 15, 30, 20. 10 by 20, so we'll go 5 by 10. See. Okay, I'm gonna make something convenient here. Let's try this. Whoa. I see. Slight issue. So right now we are kind of stuck at a 15 by 30. So we need to make some adjustments because of here, yeah. What is, oh, these are their max numbers, I think. Okay, so we have an eye at least. Let's see the pupil. Uh, what do we have? 15. Oh, exactly. Get the. Okay, I think it has to do with. It shouldn't be divided by 2. We can do like divide by. Uh, Why is it not centered? Because this was on 8, so we need to do. Wait, how many? I forgot what our original pupil size was. It was 8. 8 relative to. I don't think we had a specific value. Okay. Keep 6. Okay, here, so this is where we can make it. Pupil. Yeah, so then we can do this out. And the last thing would be or here. Okay, let's move these out. Okay, so yeah, when you get the code and you want to make changes, I think these are the only things you really need to change. So let's double check this really quick. If I set this to, I want to try this smaller one again, 4x8, 4x2. Oh, oh, well, yeah, it's still an I, just really small. This one. Yeah, it's kind of rough. So it can't be this small, I think. Maybe like a 5x10 might be okay. Yeah, because it's better if each of them is a even number, maybe. Yeah, it's better if both are even. Um, that part didn't really matter. That was just me making stuff easier. When you program in the future, you could this could be a later thing, but it's really helpful when you learn how to like substitute values in your code for variables, just so you don't have to go through every bit of code make make like a change align with what already exists. And yeah, I'm sending you to that for classrooms.
Okay.
Yeah.
All right, good job, everybody. Hey, Alex, do you have any questions?
No.
It makes sense, right? Okay,
Yeah.
2D array. Good.
Oh, wrong. So I should see it. Let me know if you need me to send it again. Do you get it?
Uh, I'm refreshing my page.
Give me a second. Double check if I sent it to your email.
Yeah.
Yeah.
It might just be slow. Let me see.
Okay, yeah. You can just email me back if you or let Alex know
Oh,
that
okay, I
you
got
didn't
it.
get it. You
Yeah,
got
I
it?
got
Okay.
it. Yeah.
Okay. Well, I mean, finish the eye today.
Good
So
job.
next
All
next
right.
episode, yeah.
Um, okay. Alex, so making sure you go over everything, all right? It's very important.
Okay.
Yeah, and I can tell you, CMU has a great computer science program, one of the best. It's a top one, yes, the best. And CMU also works on biochem, AI, cybersecurity, lots of AI computer science implementation. So therefore, this eye tracker is, hey, oh, wait a sec, Mark, what do you think? This eye tracking stuff,
I mean, like, what do you mean? Like, how useful I think
like
it is?
the computer science, AI, and the medical bio farms related,
I mean, yeah, we do need it.
like, well, future, so people can use these to detect possible disease, right?
Yeah, I get the I guess I get the goal.
Good. All right. Okay. Sounds good. So, Alex, good job, and I'll be seeing you next time. All right. Okay. Bye, Alex.
Okay.